Okay, hello everyone. It is 11:16 p.m. Friday, August 8th. Today was the last day of my internship, so I finished that up, and we're getting pretty close to finishing up advanced graphs. So we got at the most 4 days left, and most likely it will be those 4 days because these problems take me the entire video, each one. You were given an array called points representing integer coordinates of some points on a 2D plane where points of I is equal to x and y. The cost of connecting 2 points x and y and x of xi, yi, xj, yj is the Manhattan distance between them. I do recall something about this. I'm wondering if this was the cut edges algorithm because I remember. No, that was a hard. That was a hard. I remember doing this problem a year or so ago in my algorithms class whenever I was doing advanced graphs. I can't remember a single thing about advanced graphs anymore, at least. Uh. So we can't really necessarily do greedy here. Because, for example, let's say we had a third dot here. Or let's say we had a line. Shoot, I don't think this is Dijkstra's. I'm trying to explain how my mindset on how this works. Oh, all points can connect to all points. Interesting. Okay, so you can create an n-square approach pretty easily, where you just get the shortest Manhattan distance. So here, I'm about to do a bada bing bada boom. I'm about to do an n-square approach. That just for the shits and giggles. Um, 0.T and point G. I think it's math.abs for absolute value. Oh, just abs. So abs of pointy 0. Actually, let's do 1. Minus 0.2, 0. Okay, so this is just a curiosity, waste of time, really. Oh, interesting. Interesting. Oh, n minus one. Yeah. I mean, it's whatever. This is not even the solution, anyways. Let's look at what we gotta do. What sort of fancy algorithm we're gonna use. What? N squared times log n? Hey. Come on. This is so chopped. um... It's gonna be tuples. Because tuples are immutable. No capitalizations. Okay. What's up, big dog? I'm gonna use the default dictionary thing. Hey, Max. This is so chopped. I don't even know why I'm doing this. I probably should just pay attention to the actual way of going about this solution. Which is not how I'm doing it, but you know, we do what we do. Oh, I see the problem. I could have gone with my previous approach. Would have been fine. Oh well. If we want to, we can just Control C. Hmm. Pardon me? Did I do the math wrong in this one? No. I did not do the math wrong. Part. Oh, my connector's wrong, mother. Yeah. Okay. Well, that's interesting. Huh. Really? It's only grabbed 2? Huh. Really? Why did this only grab 2? Well, that's fascinating, ain't it? Okay, time to actually do some graph stuff instead of whatever the hell I'm doing. Component graph? Fuck. Yep, Kruskells. Oh no. I hate advanced graphs. Alright, I have a book that explains Kruskals, but honestly I might just Google it. Kruskal algorithm. I don't want the solution per se. Oh, it's greedy. Here you go. Eat my words. You know, I'm gonna pull out my book for a second, just see what I wrote about it. My professor explained it really well. I wish I stayed on top of it. Oh, I was thinking of Kosarajus. Oh my gosh. I'm assuming I'm probably going to have to do with Kosarajus. Maybe. Eventually. Not in this problem. Okay. So here, this is from my 18th lecture. It says, now we're going to go over weighted graphs, minimum spanning trees. Kruskal, we can algorithmically solve this by finding the smallest unused edge and adding it. If it doesn't make a cycle, we stop once we reach n-1 edges. The only difficult part is finding cycles. Okay, so this is why we're sorting the edges. So we use union find or disjoint set data, DSU, is that what that is? A partition of a set. A partition of a set are a group of disjoint subsets, but when union, they make the original set. A union find is similar to partition. It has two functions, find and union. It puts all nodes in their own set. If an edge is a part of two sets, then we union them. If an edge is in one set, it will make a cycle. Okay, so I have T equals an empty set, starting off with. Then for edges in the graph, I'm guessing it's sorted. If E doesn't create a cycle, then we add E to T. Okay, so what we'll do is we'll create one saying find sorry, within the edge we have two nodes, so we'll find union find one, find the second one. If they are not the same, which means they're not a part of the same set, then we will union them together, and then we'll add it. Okay, that's actually fairly easy. Alright, well, so hard part is just going to be the union find. Okay, I do remember doing this one. So here's how I'm going to do this. First I'm going to sort by weight. So first I'm actually going to get the weight. Shoot. Honestly, I'm gonna call these by by their index. I mean, realistically speaking, we don't actually need to know the points. We just need to know the length, and then just some sort of arbitrary value for a name of that point. So honestly, I should be fine to do something like for u in points. Oops. For v in points. Wait, how do I do this without going over every single one of them? Okay, that's how I do it. It's probably actually bad optimization. Wait, I still don't need to reference back to nothing, man. Alright, let's see. Okay, dope. So, yep. This gets me my edges. So this is basically just me cleaning house. Now I can do my actual algorithm. So we have for edge and edges. I don't need weight. I'm gonna say R1 equals find a view. I'm writing this out how I did it in my textbook. This is just kind of like a abstract idea of it. If R1 does not equal R2, which means they are in different sets. So if that's the case, then we will union R1 and R2. So we union their components, and we will add the weight. Okay, so we do add. Okay, and we'll do result plus equals W. Right. So now we need to build a union find. Let's see if Python has a built-in union find algorithm. Python union find. How the fuck do I make a union find? God damn it. Hey, union find. It's always the hard part. This is a good question. Do it. So it's like a recursive where it keeps finding its parent. So it's like, okay. Okay, so I'm gonna say if union find of node is equal to node, then we return node, else we will return find of union find of node. Okay, so I think that should find. And then we'll do a union, def union of UV, and we will say non-local union find. And we will say union find of U equals V. Alright, let's see if this has any sort of implementation. We're throwing a lot all at once, which is a problem per se. And the reason why is because if it has issues, we're going to have to kind of go through, okay, or it might not have issues. Let's see. Sheesh. There you go. A little slow, but you know what? We take the wins we get. We take the wins we get. I'm going to pull out my old algorithm book. Not fun, brother, not fun, but you know we do what we gotta do. It is 11:57, right before midnight, so I'm about to head to bed. But thank you for watching, and I will see y'all tomorrow.